Water is all around us on our planet Earth. It fills the vast deep oceans. It flows in long winding rivers. Many lakes, both big and small, are also full of water. The sun shines brightly in the sky. Its warm rays travel down to the earth. This sunshine warms the water in oceans, rivers, and lakes. When the water gets warm, some of it changes. It turns into an invisible gas. This gas is called water vapor. It is very light. Because it is light, this water vapor begins to float upwards, rising into the air above. It is not just large bodies of water like oceans and lakes that send water vapor into the air. Water also evaporates from other places. Plants have water in their leaves, and they release some of it into the air. This is a process called transpiration. Even damp soil slowly releases water vapor as it dries. Think about a small puddle on the street after a light shower. As the sun shines, the puddle gets smaller and smaller. Eventually, it disappears completely. The water from that puddle has turned into water vapor. It has joined the rest of the invisible moisture rising into the atmosphere. This water vapor is a gas, much like the air we breathe, but it is made of tiny water particles. Because it is a gas, it is less dense than liquid water. This means it can easily float and drift upwards. As the water vapor travels higher and higher into the sky, the conditions start to change. The air at higher altitudes is much cooler than the air near the ground. Imagine steam rising from a hot kettle. You can see the cloud of steam close to the spout, but as it rises and mixes with cooler air, it seems to vanish. The water vapor from Earth's surface behaves in a similar way on a much grander scale. When you see a puddle slowly shrink and vanish on a warm sunny day, you are watching evaporation in action. The water is not truly gone. It has simply changed its form from liquid water into invisible water vapor. This water vapor then embarks on an upward journey, carried by rising air currents. This transformation and ascent is the very first crucial step in the amazing process that eventually leads to the formation of clouds and ultimately to the falling of rain. Without this initial escape of water into the atmosphere, there would be no clouds and no rain to water the earth. As the invisible water vapor continues its upward journey, it reaches cooler parts of the atmosphere. Cold air has a secret. It cannot hold as much water vapor as warm air can. So as the warm, moist air rises and cools, it reaches a point where it has too much water vapor. The air becomes saturated. At this stage, the water vapor needs something to hold on to. Luckily, the air is full of tiny, microscopic particles. These can be specks of dust, tiny grains of pollen from plants, salt crystals from the ocean waves, or even volcanic ash. These particles are called condensation nuclei. When the cooling water vapor encounters these tiny particles, it changes back into liquid water. This change from a gas, water vapor, to a liquid, water droplets, is called condensation. The droplets of water that form are incredibly small, much thinner than a human hair. They are so tiny and light that they can float in the air, suspended by air currents. Millions and millions, even billions of these tiny water droplets begin to gather together in one area. As more and more droplets form and cluster, they become visible to us from the ground. This visible collection of tiny water droplets or ice crystals is what we call a cloud. You have likely seen condensation happen in everyday life, even if you did not call it by that name. Think about a very cold morning. You might wake up and see that the grass in your garden is covered in tiny drops of water. This is called dew. Or perhaps the windows of your house or the windshield of a car are foggy or coated with water droplets. This happens because the air near the cool surface of the grass or glass became cold during the night. The water vapor in that cooler air condensed directly onto these surfaces. Cloud formation is a very similar process, but it happens much higher up in the atmosphere. So clouds are essentially massive collections of these tiny liquid water droplets or, if it is cold enough, tiny ice crystals. They float in the sky because the individual droplets are so small and light, and because upward movements of air help to keep them suspended. There are many different types of clouds. Some look like fluffy cotton balls called cumulus clouds. Others are thin and wispy, known as cirrus clouds. Some form vast gray sheets called stratus clouds. The type of cloud depends on things like the altitude at which they form and the temperature of the air around them. Inside a newly formed cloud, those countless tiny water droplets are not still. They are constantly moving around, pushed by air currents within the cloud. As they drift and swirl, these tiny droplets often bump into each other. When two or more of these small droplets collide, they can merge together to form a slightly larger droplet. This process of droplets sticking together and growing is called coalescence. It is like many tiny specks of flour on a table. If you gently push them together, they can form a bigger clump. This is what happens to the water droplets inside a cloud, slowly but surely. As this process of collision and coalescence continues, the water droplets continue to grow. Each collision adds a little more water, making the droplet bigger and importantly heavier. Imagine millions of these tiny droplets, each one encountering others and merging. The cloud itself becomes denser as these growing water spheres accumulate within it. Some droplets might evaporate, but if there is enough moisture and enough collisions, many will continue to expand. The journey from a microscopic cloud droplet to a much larger raindrop is a gradual one, built up from countless tiny mergers within the busy environment of the cloud. Eventually, after many such collisions, some of these combined water droplets become so large and so heavy that the upward air currents within the cloud can no longer support them. They become too weighty to continue floating. At this point, the fundamental force of gravity, which pulls everything towards the Earth, takes over. These larger, heavier droplets begin to fall from the cloud, descending towards the ground below. This is the critical moment when a cloud droplet transforms into a raindrop and starts its journey back to the surface of the Earth. It is important to remember that not all cloud droplets will grow large enough to become raindrops. Many will remain small and continue to float, contributing to the cloud's appearance. However, when the conditions inside the cloud are just right, with plenty of moisture, suitable temperatures, and enough tiny particles to start condensation, the droplets can grow sufficiently large. The size of a raindrop can vary quite a bit. Light rain or drizzle consists of very small raindrops. In a heavy thunderstorm, the raindrops can be much larger and fall with greater force, all because many more small droplets manage to combine. Once these grown-up water droplets, now called raindrops, are heavy enough, they begin their descent from the clouds. This is the phenomenon we experience as rain. Rain can fall gently as a light shower, providing a soft watering for plants and the ground. Or, it can come down in a powerful deluge during a heavy storm, sometimes accompanied by wind, thunder, and lightning. As the rain falls, it reaches the Earth's surface. It lands on fields, forests, mountains, and cities. It flows into rivers, fills up lakes, and eventually makes its way back to the vast oceans. This falling water is vital for all life. The rain that falls to Earth plays a crucial role in replenishing our planet's water sources. Some of the rainwater soaks into the ground. This water, known as groundwater, can be stored underground for long periods and is an important source of drinking water for many communities. Other rainwater flows over the surface of the land. This is called surface runoff. It collects in small streams which then feed into larger rivers. These rivers in turn carry the water back towards the lakes and, ultimately, to the oceans. The journey of water is a continuous movement across, above, and below the Earth's surface. And then, remarkably, the entire process begins all over again. The sun continues to shine on the water that has fallen back to Earth, in oceans, lakes, rivers, and even on wet soil and plants. This water, warmed by the sun, evaporates, transforming once more into invisible water vapor. This water vapor rises into the atmosphere. As it rises and cools, it condenses to form new clouds. And from these clouds, given the right conditions, water will eventually fall back to Earth as rain, or perhaps snow or hail. This never-ending movement of water is known as the water cycle. So, the next time you see raindrops falling from the sky, or feel them on your face, take a moment to think about the incredible journey that water has undertaken. From being an invisible gas floating high above, to becoming part of a visible cloud, then growing into a droplet heavy enough to fall, and finally returning to the Earth. This constant natural process is essential. It shapes our landscapes, provides the water necessary for plants to grow, for animals to drink, and for us to live. Rain is a beautiful and vital part of the way our world works, a cycle without end.